Now, when it comes to alcohols, those are the ones that have a functional group of OH right here. So this makes it an alcohol since it's an alkane with an OH group attached, a hydroxy group attached. That's called an alcohol now. The rule is pretty simple. You follow the same thing except that the OH has to receive the lowest number and the suffix, the ending, ends to ol, denoting the alcohol. Otherwise, if we don't, then we would know that we have an alcohol. If there are two OH groups, then the suffix is diol and so on. Very well. So here we go. I have to number from this end to give the OH the lowest. So that first point of difference doesn't apply anymore. That was for alkanes, because again, the alcohol has to get the smallest number. In this case, that would be 1, 2, 3, 4, 5, 6, and 7. So therefore, that would be your alcohol is at 3, and then you have the 2 methyl groups at 5. So you start with that 5, comma 5, dimethyl. And now watch, you have to number the OH, otherwise we wouldn't know where it occurs at. So in this case, that would be a 3 right here. It occurred at the 3rd carbon or attached to the 3rd carbon. And you have 7, 7, 7. That's heptane if you were to have a normal alkane, but it's an alcohol. So what happens is we change the ending to ol, heptanol, heptanol. This indicates that we have an alcohol. Otherwise, if we just kept it as alkane, heptane, then there's no alcohol. So that's the key here, is you have to end with an ol. And that 3 tells us it occurs at the 3rd carbon in the chain. So you can pause and work on this one. Okay. All right, the highlighting isn't helping me here. All right, so we will just use here. So here's your longest chain. It goes 1, 2, it's not even letting me write here. Should work now. One, 2, 3, 4, 5, and 6. Right here. We still need the longest chain that includes the OH. That includes the OH. So some students may say, okay, let's start from counting from this carbon. Well, what are we going to do with that carbon? So you have to combine both. The longest chain that includes the OH, the hydroxy groups. And so I circled that because that would give me more substituents rather than just going this way. So therefore, you have, in this case, 2 hydroxy groups, and then you have an ethyl and a methyl. E is alphabetized before, so that would be 4 ethyl, 5 methyl, right here. Now, where did your OH group occur at? At 2 and 3, at 2 and 3. So that would be 2, comma 3. And then of course, what do you have here? You have 6, 6. So that would be hexane, but here's how we do it. We write hexa instead of saying hexanol for one. Since we have two of them, this is a diol. We call it hexadiol. And that diol indicates that we have two of them. So hexadiol, pentadiol, heptadiol, octadiol. You don't say octenadiol, what you include the N. You just include just the root of the name, octa, hexa, etc., and then diol.